The 5-number summary consists of, in this order, minimum, first quartile, second quartile, third quartile, and maximum. The 5-number summary can be represented on a box and whisker plot as follows. So this is a box and whisker plot. So here, this mark, which is the first mark outside the box, is the minimum. So that's 1, as we can see. Then the first vertical line of the box, that's the first quartile. So Q1 is 2. And then Q2 is the line inside the vertical line inside the box. This is the median or second quartile. So that's 7. And similarly, Q3 is the last vertical line of the box. So that is 9. And the maximum is this point, which is 11.5. And we may also find the interquartile range from here. And that's Q3 minus Q1, 9 minus 2, 7. Identifying the shape of a distribution from box and whisker plots. So if we have a shape like this, where we have a tail on the right side, and we see that, remember, this point is the median, and median is occurring earlier than the middle, then this is a skewed right situation, because now the mean will be somewhere on the right, and anytime mean is on the right of the median, that is a skewed right situation. So similarly, you can imagine what a skewed left will be. In that case, this line will be more towards the right side, the median line. And if all the 5 points in the 5-number summary, which means this, 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 and this, if they're all equally spaced, then it's uniform. And if we have a symmetric situation where the quartiles, the points in the box are the quartile. So if the quartiles are symmetric in the center, but the points are not equally spaced, then it is a symmetric distribution. Find the 5-number summary of the following data. So we will first arrange the data in ascending order. And for the 5-number summary, we want to split the data into and split equally in 2 rows. So here there are a total of 10 values. So 5 of them are in the first row. And again, we have arranged everything in ascending order, and the last 5 come in the second row. And the first quartile is the median of the first half of the data. So the median of the first row we can see is 4. 4 comes in the middle, so Q1 is 4. And then the second quartile, or the third quartile, is the median of the second half of the data. So the median of the second half we can see is 10. And the second quartile we know is the median of the original data. So original data, we have 7 and 8 in the middle, because 7 is the 5th value, 8 is the 6th value, and they both have 4 on either side of them. So median will be the midpoint of 7 and 8, which is 7 plus 8 by 2, or 7.5. So the 5-number summary is the, you first have the minimum. So minimum was 0. Then you have Q1. Actually, minimum was 0. So the 5-number summary would be 0 to begin with. And then we have Q1. Q1 is 4. Actually, this was another problem. So this is a 5-number summary. Yeah, the minimum is 0. And then the first quartile is 4. Second quartile is 7.5. Third quartile is 10, and the highest was 15, as we can see here. Find the 5-number summary of the following data. Now, previously, the data had 10 values. When we split it, it split nicely into 5 and 5. But here, you see, we have 7 values, and 7 values cannot be split into half. So what we do is, in 7 values, we can see that 6 is the median that's in the middle. So when we split, we include the median in both the halves. So the first split would be 2, 4, 5, 6, like here. And then For the second row, we again start from 6. So we repeat the median, and that way we have an equal number of values in both the rows. So Q1 here is again the median of the first half, and now in the first half we have 4 and 5 in the middle. So the median of the first half will be 4.5. So that's Q1. And for the second half we have 9 and 10 in the middle. And so the midpoint of 9 and 10 is 9.5. That will be the median of the second half, which means that will be the third quartile. And the second quartile is the median, which we already spotted to be 6. So the 5-number summary in this case is minimum, which is 2, then Q1, which is 4.5, then Q2, which is 6, and then Q3, 9.5, and then the maximum, which is 11. And another thing to note is that interquartile range is preferred over standard deviation in a skewed data because interquartile range only considers the middle 50% of the data. And in a skewed data, the outliers are lying at the end. And therefore, for a skewed data, interquartile range is preferred over standard deviation because remember, standard deviation uses all the values. And for a skewed data, we don't want to use the outliers, and therefore we just go for the middle 50% or the interquartile range.